we met again and we'll be discussing with energy and power. So this is what energy and power. So let's read the statement. So the trolley of mass of 1,5 kg is held stationary at point A, the top of the frictionless track. So we're told that this track, it is frictionless. Okay, and then it passes point P at the bottom of the incline, and it collides with the stationary 2 kg trolley is point B. So after it has passed this frictionless part, it will then collide with this box. So, and then there's nothing else for us here. So they say use the principle of conservation of mechanical energy to calculate the speed of the 1,5 kg trolley as point P. So we know that we have a formula or the principle of which says double MC is equal to changing a K plus a changing a P. P. Right. So this stands for a non-consecutive force, non-conservative, by the way. So we've took on not non-conservative forces, they're like for friction and force applied. Force applied. So in this case, there's no force applied on this trolley, and also there's no friction. As we're told that the part is frictionless. So then, which means for our WMC would be equal to 0. So we're just gonna write 0 will be equals. Then we're gonna expand our change in a key. Then it is half mv squared, which is final, minus half mv squared, which is initial. Then plus, then we'll add our AP mg h final minus mg h initial. So this equal to, so finally, okay, we know that our B half, okay, the box is 1.5. Okay, then finally, what we're told is finally most with calculate with speed is point P. So once the final speed, so we're just gonna see V squared, then minus half let's see 1.5. So since it was stationary there and this was released, we thought it was released, it was given no initial velocity, so initial velocity would be 0. Plus, okay, our mgh final. Okay, for final, we know that there's no height here. So if we substitute here in with 0, which will give us 0, so we're just gonna write 0, it, and then it's a minus T 1.5, 9.8, and then the height is 2 for the initial part. Okay, because here is our 2. Okay, then we further simplify. So half of 1.5, and then we punch our calculator. Half of 1.5, which will be okay, 3/4 V squared minus, okay. So, by the way, there was a 2 there. There was a 2 here. So I'm just gonna show that there's a 2 here. So, 2, then there's a squared here. So we're gonna save. Okay, we're gonna just punch our calculator, then there's 2 squared, and this should give you a 3 minus, okay, it's already a 0, so we're just gonna punch our calculator, 1.5 times 9.8 times 2, which would be 29.
0.4.
29.4. Then we're going to transpose the one with the variable. So we have negative 3 over 4 v squared minus p. It's a negative 3 minus 29.4. So will to be p at 32.4. Negative 32.4. So this will be equal to negative 32.4. And then you divide with 3 over 4, both sides, and they divide with the 3 over 4. Okay, 3 over 4. Then you will less the squared. Okay. So 32.4 divided by 3 over 4. Okay. So it's 43.2. So we use the square root, then the velocity will be root of 43.2. It is 6.57 meters per second. P. So yeah, I think you might want to add a download. Okay, this is our final answer. So hopefully you enjoyed the video and hopefully it was helpful to you. So if you find this more helpful, please hit the thumbs up button and also don't forget to subscribe and also share a comment below in the comment section.